Structure and Properties. Introduction. By the end of this lesson, students will be able to state the types of bonding, identify ionic and covalent compounds, state the physical properties of ionic and simple covalent compounds, give the structures and properties of giant molecules like diamond and graphite. Properties associated with ionic compounds are high melting and boiling points, conduct electricity in molten and aqueous states, hard and brittle, soluble in water. To see some examples of ionic compounds, click Next. Sodium chloride and cesium chloride are examples of compounds which contain ionic bonds. Ionic compounds have high melting and boiling points. Discuss and click Next. In sodium chloride, sodium ions Na+ and chloride ions Cl- are held together by strong ionic bonds. Since the ionic bond is formed by strong electrostatic forces, very high energy will be required to break the bond. Hence, such compounds have high melting and boiling points. Look at the structure of NaCl in the solid state. Why is NaCl in the solid state a poor conductor of electricity? Discuss and click Next. Answer. There is a strong electrostatic force of attraction between the Na+ and Cl- ions. The ions are not free to move. This results in the absence of conduction in solid NaCl. The ions would move freely if the solid is melted or if it is dissolved in water. What is the consequence? Discuss and click Next. The ions are able to migrate towards the opposite electrodes, resulting in conduction. In sodium chloride, the sodium and chloride ions are held together tightly by electrostatic forces, forming a close, packed structure. This makes sodium chloride a hard solid. To know why ionic compounds are brittle, click the Stress button. When an ionic compound is subjected to stress, slight dislocation occurs, which brings similarly charged ions together. Repulsion between like charges forces the layers apart. What can you say about the solubility of ionic compounds in water? Discuss and click Next. Ionic compounds are readily soluble in water. To understand this, click the Mix button. When sodium chloride is mixed with water, the oppositely charged sodium and chloride ions are attracted by the water molecules. The water molecules keep the ions apart. Therefore, the ionic compounds are soluble in water. Ionic bonding involves transfer of electrons from one atom to another. Ionic compounds have high melting and boiling points. Ionic compounds conduct electricity in molten and aqueous states. Ionic compounds are hard and brittle and are soluble in water. Now let us discuss the properties associated with simple covalent compounds. To see some examples of simple covalent molecules, click Next. Beryllium hydride, BeH2, and carbon tetrachloride, CCl4, are some of the simple molecules which contain covalent bonds. Covalent compounds have low melting and boiling points. Discuss and click Next. Two types of forces exist in covalent compounds. One is the attractive force that holds the atoms together in a molecule, and the other is the intermolecular force. These intermolecular forces are very weak, and so the molecules of covalent compounds are not held together tightly. So, with very little energy, these compounds can change into liquid state or gaseous state. Hence, the covalent compounds have low melting and boiling points. Covalent compounds are non-conductors of electricity. Discuss and click Next. Click on the circuit button to supply electricity. Covalent compounds do not contain charged particles or ions to carry the current. Hence, they do not conduct electricity. Covalent compounds are non-soluble in polar solvents like water and soluble in non-polar solvents like benzene. To understand this, click the Mix button. They do not dissolve in water, as polar water molecules cannot attract non-polar molecules. Covalent bonding involves sharing of electrons between atoms. Covalent compounds have low melting and boiling points and are poor conductors of electricity. Covalent compounds are soluble in nonpolar organic solvents like benzene and insoluble in polar solvents like water. Certain covalent compounds do not consist of individual molecules, but exist as a single giant molecule. Diamond and graphite are examples of giant molecules. Click on the Structure button to view the arrangement of atoms. To learn about the physical properties of diamond, click Next. Diamond has the following properties. It is hard, it is a poor conductor of electricity, and it has high melting and boiling points. Why is diamond hard? Discuss and click Next for the answer. In diamond, each carbon atom is bonded to 4 other carbon atoms by covalent bond to form a tetrahedral structure. The hardness is due to the strong carbon-carbon covalent bonds. Diamond is a poor conductor of electricity. Discuss and click Next for the answer. Answer. In diamond, all the valence electrons are involved in covalent bonding. The electrons are not free to move to conduct electricity. Why does diamond have high melting and boiling points? Discuss and click Next for the answer. Diamond has very strong covalent bonds that link up all the carbon atoms in a giant molecular structure. A large amount of heat energy has to be applied in order to break these bonds. To know the physical properties of graphite, click Next. Physical properties of graphite are: it is soft and slippery. It has high melting and boiling points. It is a good conductor of electricity. Why is graphite soft and slippery? Discuss and click Next for the answer. Answer. The different layers in graphite are held together by weak van der Waals forces which can be broken easily. The layers of atoms can slide over each other very easily. Hence, graphite is soft and slippery. Why does graphite have high melting and boiling points? Discuss and click Next for the answer. Answer. A large amount of energy is required to break the covalent bonds between the carbon atoms. Therefore, graphite has high melting and boiling points. Why is graphite a good conductor of electricity? Discuss and click Next for the answer. Answer. Graphite is a good conductor of electricity along the layers because it has delocalized electrons. The delocalized electrons can move along the layers. Diamond and graphite are giant molecules with covalent bonding. Diamond is hard and has high melting and boiling points. It is a poor conductor of electricity. Graphite is soft and slippery with high melting and boiling points. Graphite conducts electricity along the plane of carbon atoms.